Hello everyone, in this video we're going to learn how to solve quadratic equation with imaginary solutions. Alright, the standard form of quadratic equation is given by ax squared plus bx plus c equals 0, where a not equal to 0, right? Because if a equals 0, it becomes linear equation, right? Now, this guy has discriminant b squared minus 4ac. Now, the first case, if the discriminant greater than 0, the quadratic equation right here has two real solutions. It could be right here, right? And when you graph it on the x and y coordinate plane, you have two solutions, which is right here. These are two 0, right? Second case, b squared minus 4ac equals 0, then the quadratic equation has one real solution, which is x equals negative b over 2a. And this could be right here. In this situation, the quadratic function y equals a s squared plus b s plus c bounds the x-axis, right? Now the third case, b squared minus 4ac less than 0. The quadratic equation has no real solution. In other words, the quadratic equation has two imaginary solutions, which is this guy right here. Right? In this situation, the quadratic function right here does not touch the x-axis nor intersect the x-axis. It's above the x-axis, right? Example number 1. Find the discriminant and use it to determine if the equation has one real solution, two real solutions, or two imaginary solutions. Alright, so we need to convert this one to standard form. So it's going to be negative 3s squared plus 9s. Subtract 4 both sides, it's going to be minus 4 equals 0, right? So a equals negative 3, b equals 9, and c equals negative 4, right? Then you have the discriminant b squared minus 4ac. It's going to be 9 squared minus 4 times a equals negative 3 times c equals negative 4, right? And if you simplify this one, it's actually 33, which is greater than 0. Then the original equation has two real solutions. Question B. We're going to rewrite this one in standard form first, right? So we have 10s squared minus 2s, subtract 3s both sides, right? Plus 2, and then add 4 both sides, right? Equals 0. Now we're going to simplify this one, so it could be 10s squared minus 5s plus 6 equals 0, right? So a equals 10, b equals negative 5, and c equals 6, right? So discriminant b squared minus 4ac equals negative 5 altogether square minus 4 times 10 times 6, right? So if we simplify this one, it could be negative 215, which is less than 0. Then original equation has no real solution. In other words, it has two imaginary solutions, right? Now let's move on to example number 2. We're going to solve the following equations. So we're going to convert this one to standard form first, right? So I have 1/2 s squared minus 3s, subtract 3s both sides, right? Plus 2, add 1 both sides, right? It's going to be 0. Now we're going to simplify this one, so it could be 1/2 s squared minus 6s plus 3 equals 0, right? If you see the denominator, just multiply both sides by denominator, right? So I'm going to multiply both sides by 2. It turns out to be s squared minus 12s plus 6 equals 0, right? So a equals 1, b equals negative 12, and c equals 6, right? Then discriminant b squared minus 4ac is negative 12 squared minus 4 times 1 times 6, right? It's going to be 120. Greater than 0. Then original equation has two real solutions, right? It's going to be s equals negative b plus minus square root of b squared minus 4ac divided by 2a, right? So it's going to be negative of negative 12 plus minus square root of 120 divided by 2 times 1, right? So it's going to be 12 plus minus square root of 120 can be written as square root of 4 times 30, right? Bring 4 outside turns out to be 2 root 30, right? So I have 2 root 30 divided by 2, right? So I'm going to simplify this one, divide the top and bottom by 2. It's going to be 6 plus minus root 30, right? Now question B, we do exactly the same thing, right? So I'm going to turn this one into the standard form, right? So it could be negative s squared plus 6s squared both sides, right? Then we're going to add s both sides. And then add 1 equals 0, right? So it turns out to be 5s squared plus s plus 1 equals 0, right? So then we have a equals 5, b equals 1, and c equals 1, right? So b squared minus 4ac equals 1 squared minus 4 times 5 times 1, right? So it turns out to be negative 19, which is less than 0. Then original equation has two imaginary solutions, right? It's going to be s equals negative b equals 1, so negative 1 plus and minus square root of this guy, which is negative 19 divided by 2 times a equals 5, right? So it turns out to be negative 1 plus and minus square root of 19. Now remember, we have I squared equals negative 1, right? So negative 19 can be written as 19i squared, right? Divided by 10, right? Now we're going to simplify this one. It turns out to be negative 1 plus and minus I squared root of 19 divided by 10, right? Now let's move on to example number 3. Write a quadratic equation in standard form that has the given real solutions. Alright, so remember the two real solution is given by the formula negative b plus minus square root of b squared minus 4ac divided by 2a, right? So I'm going to equate the bottom right here. So I have a system of equations 2a equals 14, right? And the top right here, I look at 9 and negative b right here. So I have negative b equals 9, right? And the last one, I have b squared minus 4ac right here equals 249, right? So I just solve a system of three equations right here. So it turns out to be a equals 7, right? b equals negative 9, right? And substitute these two values into the third equation right here. So we have b squared is going to be negative 9 altogether square, right? Minus 4 times a, which is 7, times c equals 249, right? So then I'm going to simplify this one. It's going to be negative 28c equals 249. Negative 9 squared equals 81, right? Subtract 81 both sides, right? So negative 28c equals 168. So divide both sides by negative 28 and c equals negative 6, right? Now the quadratic equation is as squared plus bs plus c equals 0. We're going to substitute these three values into the equation. We have the answer is 7s squared minus 9s minus 6 equals 0. Now question B is similar to question A. I'm going to leave this one for you to practice. I'm going to give you the answer for you to check. It's going to be 8s squared plus 3s minus 11 equals 0, right? Now let's move on to example number 4. write a quadratic equation in standard form that has the given imaginary solutions. Alright, so these guys are two zeros of the quadratic equation, right? So we can write this one in factor form first, right? So this guy turns out to be s plus 5i times s minus 5i equals 0, right? We just distribute this one, so it could be s squared minus 5i s plus 5i s minus 25i squared, right? Equals 0. Now this guy cancel out, right? So we have s squared minus 25i squared equals 0. Note that I squared equals negative 1, right? So negative 25 times negative 1 turns out to be positive 25. So s squared plus 25 equals 0 is the final answer, right? Similarly, we have s minus parenthesis negative 3 plus 2i square root 2, right? Times s minus negative 3 minus 2i square root 2, right? Equals 0. Now we're going to simplify this one, so it's going to be s plus 3, right? We just distribute negative 1 over here, so it could be minus 2i root 2, right? Times s plus 3 plus 2i root 2 equals 0, right? Now consider this one a, this one b, this guy a, and this guy b. So we have the formula a minus b times a plus b. This guy actually a squared minus b squared, right? So we have s plus 3 altogether square minus b squared, which is 2i square root 2 altogether square equals 0, right? Now remember, we have complete square formula a plus b altogether square is going to be a square plus 2ab plus b square, right? So it's going to be s square plus 6s plus 9, right? And this guy square equals 4, right? I square equals negative 1, right? And square root 2 square equals 2, right? It's going to be 0. Now we're going to simplify this one, so s square plus 6s, right? Negative 4 times negative 1 equals 4 times 2, it could be 8, plus 9, it could be 17, equals 0. This one is the final answer, right? Now example number 5. Find the values of k so that the equation has 2 real solutions, 1 real solution, and 2 imaginary solutions, right? So in order to do that, we need to calculate the discriminant, right? So we know that a equals 1, right? B equals negative 2k, right? And c equals k. So we have b squared minus 4ac equals negative 2k altogether square minus 4 times 1 times k, right? We're going to simplify this one, so it could be 4k squared minus 4k, right? So case number 1, 2 real solutions. So in order for the quadratic equation to have 2 real solutions, the discriminant must be greater than 0, right? So we have 4k squared minus 4k greater than 0, right? Now we're gonna factor 4k out, so it could be k minus 1 greater than 0, right? So I just find the 0 of this one. 4k equals 0, then k equals 0, k minus 1 equals 0, then k equals 1, right? Place these two 0 on the number line. 0 right here, 1 right here. The left hand side is negative infinitive, right hand side is positive infinitive, right? Now I'm going to test one interval, right? So I'm going to pick 2 here. Substitute 2 for k back to the original 1 right here, right? So it turns out to be 4 times 2 square minus 4 times 2, right? which is 16 minus 8. This guy positive, right? So right here we have the positive side, and then we keep changing the sign, so it could be negative, positive, right? Now finally, we look at the inequality right here. We need positive, right? So your solution should be this interval right here because it's positive right here, and this interval right here, right? And you need to write negative infinity, comma 0, union 1, comma positive infinity. We're not going to include the zeros right here because we don't have equal sign right here. If we have equal sign right here, and then the guys right here must be the bracket, so keep that in mind. Now B, one real solution. Then we have 4k squared minus 4k equals 0, right? We just solve this quadratic equation by factoring, right? So factor 4k out, so it could be k minus 1 equals 0. Then 4k equals 0, or k minus 1 equals 0, right? We solve this one, so it could be k equals 0, k equals 1. These are two values of k, right? And the last one, two imaginary solutions, right? We have 4k squared minus 4k must be less than 0, right? So we're going to use the equation A right here, less than 0, which is this interval right here, right? So your solution must be 0, 1, right? This guy right here. Now, question B, similar to question A, right? We have A equals 3k, B equals 2, and C equals 3k, right? Then we're gonna calculate B squared minus 4AC, right? And I'm gonna leave this one for you to practice. I'm gonna give you the answer. For the first case, two resolution, k must be between negative 1 over 3 to 1 over 3, right? One resolution, k equals negative 1 over 3, or k equals 1 over 3, right? Two imaginary solution, k less than negative 1 over 3, or k greater than 1 over 3, right? Now, example number 6. Suppose q less than p less than 0. Tell how many real solutions each equation has. So, we need to find the discriminant, right? A equals p, b equals q, and c equals negative p, right? So we have b squared minus 4ac. It's gonna be q squared, right? Minus 4 times p times negative p, right? So it's gonna be q squared plus 4p squared, right? And we look at the condition right here. It tells us that this guy always greater than 0, right? So then the equation has two real solutions, right? Now question B. A equals q, B equals p, and c equals q, right? So we have b squared minus 4ac. It's gonna be p squared minus 4 times q times q, right? So it could be b squared minus 4 q squared, right? So observe that q less than p, right? It tells us that this guy less than 0, right? Then the original equation has two imaginary solutions. Now let's move on to example number 7. The demand equation for a DVD player is given by P equals 110 minus 0.0001 S, where P is the unit price in dollars of the DVD player and S is the number of DVD players sold. The cost equation for the DVD player is given by C equals 55S plus 150,000, where C is the total cost in dollars of producing the DVD player and S is the number of DVD players produced. The total profit P obtained by producing and selling S DVD players is given by P equals S times little p minus c. Question A. Write the total profit equation for the DVD players in terms of S. We have the total profit is given by this one, right? Little p is given by this guy right here. And then subtract the cost. The cost is given by this one right here. It's going to be negative 0.0001 s squared, right? And then s times 110 is going to be 110s. Subtract 55s is going to be plus 55s, right? Distribute 1 right here is going to be negative 150,000, right? This one is the answer. Now question B. Determine the unit price that will yield a maximum profit. So this guy actually the quadratic equation, right? So quadratic equation obtain the maximum as the vertex, right? So we have the x coordinate of the vertex is s equals negative b over 2a, right? Where a equals negative 0.0001, right? B equals 55 and C equals negative 150,000, right? So we substitute over here, we have negative B is going to be 55 divided by 2A, which means 2 times negative 0.0001, right? Now, if you use calculator, the answer must be 275,000, right? Now, to find the unit price, we're gonna substitute this value into the equation right here, right? So we have little p of 275,000. It's gonna be 110 subtract 0.0001 times 275,000, right? So your answer must be $82.5. Now let's move on to question C. Determine the unit price that will yield a profit of $10 million. It is possible. Alright, so we just let this guy right here equal $10 million, right? It's going to be capital B right here. Now we're going to solve this quadratic equation, right? And make sure discriminant greater than 0, right? Now subtract 10 millions both sides and then simplify. We're going to get. Then we're going to multiply both sides by negative 1. So we have. Now we have A equals 0.0001. B equals negative 55. And C equals 10,150,000, right? Now we're going to find discriminant B squared minus 4AC. It's going to be negative 55 squared minus 4 times 0.0001 times 10,150,000, right? Observe that this guy always less than 0, right? So then the equation right here has no real solution, right? So we need to answer this one is impossible, right? It's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.